Good morning, students. In earlier classes, we discussed about electricity related concepts. Before Orested experiment, scientists thought that electricity and magnetism both are different concepts. There is no relation between electricity and magnetism. That was the concept of scientists before Orested experiment. After Orested experiment, same scientists said that electricity and magnetism both are interrelated concepts. Because of electricity, we can produce the magnetic field. Because of magnetic field, we can produce the electricity. So that is the importance of Orested experiment. So according to Orested experiment, for example, this is a current carrying conductor. Some high amount of current is passing through this conductor. When the current is passing through this conductor, magnetic field will be produced around the current carrying conductor. So that is the Orested experiment. According to Orested experiment, magnetic field can be produced around a current carrying conductor. So after that experiment, the scientists said that electricity and magnetism both are interrelated. So according to Orested, when the current is passing through a conductor, some magnetic field will be produced around the current carrying conductor. Afterwards, Biot-Savart, so these scientists has given a mathematical expression for the production of magnetic field around a current carrying conductor. So Orested has given the explanation and practical evidence for the existence of magnetic field around the current carrying conductor. Then after, this Biot-Savart has given a mathematical expression for the produced magnetic field when the current is passing through a conductor. So today we are going to discuss Biot-Savart's law. So according to this law, so this is a current carrying conductor, XY is a current carrying conductor. So through this conductor, I amount of current is passing through this one. And I have taken a small elemental length dl on the current carrying conductor. This is the dl element. So according to Orested, when the current is passing through this conductor, some magnetic field will be produced around the current carrying conductor. So to find out that magnetic field, we have chosen a point P at a distance r from the elemental length dl. So the distance between dl element and point P is r, and theta is the angle between this position vector and elemental length. So this is the theta. Theta is the angle between element and position vector. Now according to Biot-Savart, the produced magnetic field is directly proportional to three concepts. One is the produced magnetic field is directly proportional to the amount of the current which is passing through the conductor. That means dB is directly proportional to I. And second one is the produced magnetic field is directly proportional to the length of the element. That means directly proportional to dl. And the produced magnetic field is directly proportional to the sine of the angle between elemental length and position vector, that is sine theta, and inversely proportional to square of the distance between the point P and dl element. So this is the mathematical expression was given by Biot-Savart. So the produced magnetic field is directly proportional to the amount of current which is passing through the conductor, and directly proportional to the length of the element, and directly proportional to the sine of the angle between dl element and position vector, and inversely proportional to square of the distance between the point and dl element. Now when you combine all these things, then what happened? dB is directly proportional to I dl sin theta by r square. When you remove the proportional, you can get some proportionality constant, that is mu naught by 4 pi I dl sin theta by r square. So this is the mathematical expression of the production of magnetic field around a current carrying conductor according to Biot-Savart. In vector form, just multiply and divide with r. Then in denominator r square into r cube, and here dl r sin theta. So in vector form, sin theta can be written as cross product. So dl r. So this is the magnitude of the production of magnetic field around a current carrying conductor, and this is in vector form, mu naught by 4 pi I dl cross r by r cube. So this is in vector form, and mu naught value is 4 pi into 10 power minus 7 Henry per meter. Mu naught is nothing but permeability of the free space, and magnetic permeability can be defined as it is the measure of the degree to which magnetic field can penetrate through the material. So how much magnetic field can be penetrated into the material was given by this magnetic permeability. It is represented by mu. So this is called Biot-Savart's law. So you can find the statement here. So the magnetic induction due to a current carrying element is directly proportional to, number 1, the current flowing through it, that is I. Number 2, the length of the element, that is dl, and the sine angle between the radius vector and element, that is sin theta, and inversely proportional to the square of the distance between point and element, that is r square. So when you combine all these things, you can get this one. So the produced magnetic field is directly proportional to the amount of current which is passing through the conductor and the length of the element and sine of the angle between this elemental length and the position vector, and inversely proportional to square of the distance. So this is called Biot-Savart's law. According to this equation, we can find the produced magnetic field around a current carrying conductor, and that current should be a constant current. So when a constant current is flowing through a conductor, the produced magnetic field is this one. So this is our Biot-Savart's law. Thank you.